All right. Today we are doing the second day of 9.4 and 9.5. So yesterday we learned what the trig functions are, sine, cosine, and tangent. Today we're going to be using those trig functions to find missing sides of right triangles. So the nice thing is you can be given a right triangle with only one side that you know the length of, and you can be given an angle. And then you can use all of that information to help find the length of any missing sides. Whereas with like the Pythagorean theorem, you need at least two sides in order to find a missing side. This will work if you only have one side. So let's go ahead and we'll get triggy with it. And grab your notes. Maybe. Come on, camera. There we go. All right, that looks pretty focused. For our focused notes. Okay, so 9.4, 9.5, this is part 2. We are going to be finding a missing side with sine, cosine, and tangent. Okay. So for those of you who really like steps and things like that, we are going to have steps that you can use today to solve these kinds of problems, so you're in luck. Just to remind ourselves real quick, we had so, ka, toa. It's a good thing to have on the top of your paper usually when you're doing this. And so, remember, tells us that sine is opposite over hypotenuse. Ka tells us that cosine is adjacent over hypotenuse. And tangent tells us that, or toa tells us tangent is opposite over adjacent. So that's a good thing to keep in mind as we go through these kinds of problems. And the easiest way to kind of learn how to do these kinds of problems, I think, is to just go through some examples of how it works with steps and things like that. So I'm going to put that off to the side. And example number 1. We're going to be given this triangle here, A, B, C. This is a 65-degree angle. We know this side length is 14, and we're looking for the two missing sides. Okay, so this is one way that this question might be asked. They might ask us to find the value of x and y. Or they might just ask for the value of x or just the value of y. But in general, find the value of x and y. And so in this kind of a scenario, they've already got variables labeling the two missing sides. You could also be asked to like find the length of BC or find the length of AC. But if you were asked to do that, the first thing that I would do then is go and label the sides that are missing with a variable. That way, when you go to put it into an equation, it's a little bit less murky and confusing. Okay, so step 1. Label the sides with respect to the angle that you know. And when I say label the sides, I mean label them opposite, adjacent, and hypotenuse. Okay, so when I go to label the sides with respect to the angle that I know that this is a 65-degree angle here. And so that means this is the angle that I'm looking from this angle's perspective here. So the opposite side would be the one with the X labeling it. The adjacent side would be the one with the Y labeling it. And then the hypotenuse is the other side length that we know. Okay. Let everyone finish writing. Okay. And so for finding X and Y, I'm going to go through these steps separately for finding X and separately for finding Y. So to find X, we want to choose the trig function, sine, cosine, or tangent. Based on the side that we know and the side that we're looking for. So that means if we're looking for X, that means we've got opposite is the side that we're looking for, and hypotenuse is the side that we know. So opposite is the side we're looking for, hypotenuse is the side that we know, and so based off of that, I'm going to use sine. But for y, the side that I have, or the side that I'm looking for is the adjacent side, and the side that we know is the hypotenuse. So to find y, I would use cosine. Okay, so now we've chosen, we're going to use sine and we're going to use cosine for this problem. Step 3, we're going to set up equations using the trig functions from above. Okay, and so the way that I'm going to do that is for x first. I know that I want to use sine. So I'm going to go sine of 65. The angle always goes inside the sine or the cosine. So since I know this 65-degree angle, that's what's going inside sine. And then equals, and then we know that sine is equal to opposite over hypotenuse. So opposite over hypotenuse would be x over 14. X over 14. And now what we want to do is solve this equation. And so to solve this equation, to get x by itself, all we have to do is multiply by 14 on both sides. So now we get 14 sine of 65 is equal to x. And this can be typed into the calculator. So if you're using Desmos, great. If you're using a scientific calculator, that works too. I'm going to use this calculator, and all we have to do now is type 14 sine 65 into the calculator, and we get an answer. If you plan to use Desmos, make sure that you put your calculator into degree mode first. So I'm going to show that real quick. So if you're using Desmos, if you want to get a window of that open, make sure you click the wrench first, and then go down to the bottom and click on degrees. Otherwise, it will give you answers that don't quite work out. So click on degrees, and then you would type 14 sine 65 and get the same answer that we just got on the regular calculator. Okay, so then our answer would be, depends on what you would like to round or what you're being asked to round to. I'm in the habit of rounding to 3 decimal places, 12.688. If you're asked, like on an IXL section, to round to the nearest tenth, you would get 12.7. If you're asked to round to the nearest hundredth, so 2 decimal places, you would get 12.69. Or if you're rounding to 3 decimal places, you would get 12.688 equals X, and that would be your answer. Okay, so now we have found X. Any questions about that? Any numbers we're not sure where they came from or why they went where they did? Okay, then we're going to go ahead and solve for y now. Doing the same kind of thing, except this time with cosine. Because up here we decided that for y, since we have adjacent and hypotenuse that we're working with, we want to use cosine. So for y, we're going to set up the same kind of thing. It's going to be cosine of 65 equals y over 14, since it's adjacent over hypotenuse. And then we'll do the exact same kind of method to solve it. We'll multiply by 14 on both sides. So we get 14 cosine of 65, which is what we're going to type into the calculator. Okay, so then we would go into the calculator and go 14 cosine 65, enter, and we would get that y is 5.917. And again, if you would like, if you're asked to round to different decimal places, like just 1 decimal place would be 5.9, or 2 decimal places would be 5.92, 3 is 5.917. Okay, so it really just depends on what you're asked to round to then for finding your final answer. But this is how we would solve for those 2 missing sides using sine, cosine, tangent. Okay, any questions from that one? Any numbers we're not sure where they came from? Steps we're wanting to go back to? Okay. Then we're going to do another one. Get some more practice with this. All together. And I won't write out like the lengthy steps this time, so this example will go a little bit quicker. So this time, still got a right triangle going on. Triangle PQR this time. This angle is 32 degrees. This side here is 7, and we are missing these two sides. Okay. So step 1, label all of the sides with respect to the angle that you know. So the angle we know is angle P. Go ahead and label the sides opposite, adjacent, and hypotenuse with respect to angle P. When you've got your sides labeled, put "got it" in the chat. Caleb's already got it. Quick, that one. Adon's got it. Kaylee's got it. Awesome. Nice job, Jade. Good job, Ashton. All right, 10 seconds. All right, what did we put for the opposite side? Seven, right? 7 would be the opposite side here. How about adjacent? Exactly. Adjacent is y, and then hypotenuse, process of elimination here, also it's across from the right angle, would be x. All right, so now we have opposite, adjacent, hypotenuse going on. So that was step 1, taken care of. Step 2, we're choosing sine, cosine, and tangent to help us solve for x and for y. So for x, to figure out what x is, we want to choose based off of the side that we're looking for and the side that we know the length of. So the side that we are looking for is x, that's the hypotenuse. The side that we know the length of is the opposite. So am I going to use sine, cosine, or tangent to solve for x? What do we think? Which one uses opposite and hypotenuse? Let's look at our notes here. We had so, ka, toa. Which of these three for sine, cosine, and tangent uses opposite and hypotenuse? Exactly. Thanks, guys. Yeah, so or sine. Sine uses opposite and hypotenuse, so that means we're going to use sine to find x. It's going to be sine of 32 to set up our equation, because that's our angle. The angle always goes inside. And then it's equal to opposite over hypotenuse. So in this case, opposite over hypotenuse is 7 over x. So let's go ahead and solve for x, and then we'll move along and solve for y. So solving for x, this one's a little bit trickier. It has one more step because the x is on the bottom, whereas in the last question, the x was on top. So this time I'm going to multiply by x on both sides and rewrite it. We have x sine of 32 equals 7. Then to get x by itself, I'm going to divide on both sides by sine of 32. So in my calculator, I'm going to type this. 7 divided by sine of 32. So here we go with the calculator. 7 divided by sine 32. Enter. And we get 13.21. So x equals 13.21. All right, so we solve for x. Now we want to solve for y. And for y is the adjacent side. And then the side that we know is the opposite side. So looking at our three trig functions, sine, cosine, and tangent, which one uses adjacent and opposite? Tangent, exactly. TOA, tangent is opposite over adjacent. So we're going to use tangent. And specifically, tangent of 32 equals opposite over adjacent, so 7 over y. And then we're going to solve this the exact same way that we solved this one over here. So we're going to multiply by y on both sides. We get y times tangent of 32 equals 7. Then we'll divide by tangent of 32 on both sides. And then we put this into the calculator. 7 divided by tangent of 32. Enter. And we get 11.202. Okay. So looking at either of these parts here, is there anything we want to go back to? Any numbers we don't know where they came from? Okay. Then gonna have you guys try one. Here's our triangle. STP. And let's see, we know that this side is 8 units. This angle is 42 degrees. Go ahead and solve for x. So just x so far for this one. And I'll kind of step us through, give you hints as we go. But once you think you've got x, go ahead and type "got it" in the chat. If you're not sure where to start with labeling your sides with respect to this angle. All right, if you started by labeling them as opposite and adjacent, You're correct. You're on the right track. Also, if you made the decision then to use tangent, you're on the right track. All right, and if you set up the equation, tangent of 42 equals x over 8. You're on the right track here. And then if you multiply by 8 on both sides, that's your last step. Then you type it into the calculator. So then for x, we should get 7.203. All right. Now, go ahead and solve for y as well. Knowing that y is the hypotenuse. For y, if you chose to use cosine, you're on the right track. You have adjacent and hypotenuse. Adjacent is the one that you know. Hypotenuse is the one you're looking for. So cosine is adjacent over hypotenuse. So if you set up cosine of 42 equals 8 over y, you're on the right track there. Also, just something to mention, this way that I'm showing you to do this is one way you can do it. If you found another way to do it, you've been thinking about it and you decided to find the other missing angle and do things from that angle's perspective or something like that, you're welcome to try that. As long as you get the same answers that we're getting using this method, then really you're good to go. You can use different methods as long as they work. All right, so for this one, you're gonna have to follow the same kind of solution pattern as we did up here. You're gonna multiply by y on both sides. And then what you have to type into the calculator is that 8 divided by cosine 42. So if you got 10.765, you are correct. Some of you might be starting to see a little bit of a pattern here as well. When you've got the variable on the bottom, you end up taking the number on top and dividing by the trig function. So if you want to skip that step, if you feel like you're ready to at that point, and when you've got the variable on the bottom, just jump to dividing, feel free. If you prefer to write it all out and make sure that you've got everything lined up, that's good too. Okay. Let's do another example here, or another you try, and we'll kind of walk through this one as well, just to get us a little bit more practice together before we split off and start doing the assignment. So this is you try 1, this is you try 2. So we have triangle DOG. We'll say this angle is 64 degrees. This side length here is 43 units. Go ahead and solve for x. All right, I'm going to be a little bit slower with the help on this one. So if you think you've got it already, make sure you type "got it" in the chat whenever you think you have it. All right, a couple of us have it already. Nice job. If you started off by making sure that you label that this is the opposite and the hypotenuse, then you're on the right track. And then we would want to set up the equation sine of 64 equals x over 43. That's what you did. Awesome. Then you want to multiply by 43 on both sides, and then type 43 sine of 64 into your calculator to get 38.648. All right. Then if you've already solved for x, go ahead and solve for y as well. And when you think you've got y, type "got it" in the chat. All right, Jade's quick. Nice job. Caleb's got it. Adon, Lauren, nice. Coming in quick. Yeah, this one's pretty much just like the other one except with cosine instead. All right, so for this one, setting up for y, we know that y is the adjacent. So this time we're going to do cosine of 64 equals y over 43. Then multiplying by 43 on both sides, we can then type 43 cosine of 64 into the calculator. And we should get 18.85. So if that's what you got, awesome. All right, so at this point, we're going to do a quick poll. So if you go to the poll section, on a scale of 1 to 5, how are we feeling about finding missing sides? 1, I need a lot of help, would like more examples, that sort of thing. 3, I probably just need some practice on my own. 5, this is super easy. What are we feeling? I would like everybody to please vote. Got 30 more seconds to vote. Everybody please vote. Nobody else will see what you voted, just me. But I know there's more than 10 people here. Or there should be more than 10 people here. All right, 10 more seconds. Get your votes in. Okay. So, let's see. Based on that, I think what we'll do is I will post the homework. We'll talk a little bit about it, and then if anybody would like to stick around and do some more examples with me or go over anything specifically from your IXL section, like get help starting the homework and stuff like that, we can. So I'm going to go ahead and post it. Where did it go? Did I only post it in the third quarter one? I did. Okay. Or in the third period one. Okay, so today's homework assignment is going to be IXL R8 to a SMART score of 80. So it's just one IXL today. Might have to refresh the page to get there. But here it is. It's IXL trigonometric ratios, find a side length. And you'll want to log in. But anyway, they'll say things like find TU. So what I would do if I were you first is assign like a variable like X to side TU. I would also make sure that whenever you're doing IXL, as always, have some paper and pencil to do your work on. So I would label this as like side length X. And then from there, notice that this is a 24-degree angle here. So we're working from this angle's perspective. And then this side length is the adjacent. This one is the hypotenuse. And so then I would use that to start off with cosine. Then write your answer as an integer or a decimal rounded to the nearest tenth. So on this one, we're rounding to just one decimal place. So on the whole, I know on most of the notes, we rounded to like 2 or 3 decimal places. This time you're just rounding to 1 decimal place for all of these. Okay. And then I will also post an exit ticket in just a couple of minutes. But this is the part where if you would like some help, if you would like to go over any of the IXL problems with me, feel free to stick around. Otherwise, you are free to, actually, we have HSBP today as well. So just another reminder, it's the same stuff as before, making sure that you get your class, or that you register for your classes. So I'll go through that again real quick.